Well, before we can even think about this limit, we really need to understand a little bit about the natural log function. Like, what's its graph look like, okay? So, in order to understand that, of course, I hope you know, but maybe not, that you probably knew at one time, but might have forgotten, that the natural log is the inverse of the exponential, the e to the x function, okay? Now, logarithms are inverse to exponential functions. Logarithm to any base is inverse to the exponential function where that base is raised to the x power, okay? Well, we can then make a table for the e to the x function, the exponential function, the fundamental exponential function, okay? So we're just going to go from x equals -2 to 2, which will tell us, once we see the pattern between -2 and 2, we'll be able to understand what happens, okay? So, evaluating e to the x, well, if x is -2, we get e to the -2, and, and so forth on up to e to the second. E to the 0, as you say, is 1. E to the 1 is e, and that's approximately 2.7. That's close enough to get a picture of the graph. If you want to be more exact, well, take the limit as n approaches infinity of 1 plus 1 over n, okay, to the n. Okay, so anyhow, e squared then is approximately 2.7 squared, which is approximately 7.3, right? Now, how are we going to calculate e to the -1? What's that mean?
1 over e.
Yeah. Very good. You beat me. Okay, you said it just before I wrote it. Meaning you understand it. Boy, something just flashed. It might be the battery's dying. Anyhow, let's see if we get this done. And that's approximately 1 over 2.7. Okay? And I think that's approximately 1 over 2.5 would be 4. 1 over 3 would be 0.33. Interpolate, and I think you get something pretty close to 0.37, although it could be off. Okay? And then you divide that by 2.7.